Looking at graphical method of simultaneous equation. So to solve this, the question said draw the graph of y equal to 3x minus 4 for values of x from minus 3 to plus 3. Okay, what this means is that, let's draw the table. This is the table. Okay, here we have the equation y equal to 3x minus 4. Okay, and the question said for values of x from, that means this x will be numbers from minus 3 to plus 3. So let's do this. Let's put it on the table. So this place is our x, this place is our y. So the x will be from minus 3 to plus 3, that is minus 3 minus 2 minus 1 0 1 1 2 3. Okay, so what we are going to do now, we are going to be putting this x, these values of x, inside this formula to be getting our y, where we'll be using, where we are going to input here. Okay, so for the first one, we have y equal to 3x, that is, we are going to use this first one now, minus 3 minus 4. This one now will be equal to minus 9 minus 4. So minus 9 minus 4 give us minus 13. We're going to put minus 13 here. Do it again for this one. We have y equal to 3x. Now this time we're going to put minus 2 minus 4. So 3 times 2 is 6, negative sign, so minus 6 minus 4, which will give us minus 10. I'm going to put minus 10 here. So do it again for this one. Y equal to 3 minus 1 minus 4. So that is minus 3 minus 4, which will give us minus 7. Again, y equal to 3x, this time 0 minus 4. So 3 times 0 is 0 minus 4. 0 minus 4 is what? Minus 4. Again, y equal to 3x, this time is 1 minus 4. So that is 3 minus 4, which is minus 1. Y equal to 3x, this time 2 minus 4. So 3 times 2 is 6 minus 4, which will give us 2. Lastly, we have y equal to 3 times 3 minus 4. So 3 times 3 is 9 minus 4. 9 minus 4 will give us 5. Okay, so we've completed this table now. So let's draw the graph of these values. So this is the graph of this is the value, this is the graph of the value. The vertical side is our x-axis, while the horizontal side is our the vertical side is our y-axis, while the horizontal side is our x-axis. Okay, and the scale of the graph is 1 centimeter to 1 unit for the x-axis. You can see this is the x-axis. We start counting with 1 unit, that is 1 2 3 4. So their differences are 1. Okay, and 1 centimeter, that means we assume that year to year is 1 centimeter, 1 to year is 1 centimeter, 1 to year to year is 1 centimeter. So if it's a real graph, you should understand it will be the real 1 centimeter. Okay, so the scale of the vertical axis y, we make this scale 2 centimeter to 2 units. We assume that year to year is 1 centimeter. That means if we add another 1 centimeter, that means year to year is 2 centimeter. That's what we assumed. Okay, so year to year is 2 centimeter. Year to year also is 2 centimeter. So that's their differences. And these 2 units here means we're counting in twos. That is 2 4 6 8. Okay, this one is 1 unit, so we're counting in ones. 1 2 3 4 5. But since it is 2 units, we're counting in twos. 2 4 6. So the 1 centimeter means this distance here, we assume this distance to be in 1 centimeter. 1 centimeter. Why this one 2 centimeter? That means we assume that this place is the 1 centimeter for the vertical, while adding another one again will make it 2 centimeter. That means from here to here is 2 centimeter. You can see that's why we wrote 2 here. So now let's input these values in our graph. This is for the x and this is for the y. So let's start. We have minus 3, minus 13. This is minus 3 for the x, and this is minus 13 is below. Let's check. Okay, this is minus 3 here, and this is minus 13. Since this is 10, 12, 14, that means here will be 13. You notice, kind of like here can be 1, minus 1, minus 2, minus 3, minus 4, minus 5. But I just didn't write it there because I just wanted to understand how to write the scale of 2 centimeter to 2 units. But that's what it means. The middle here will be 7. The middle here will be 9. The middle here will be 9, 11, will be 11, 10, 11, 12. That means this place here is our 13. Okay, and from the table we have that we should link minus 3 to minus 13. So let's link them together. So since this is minus 12, that means here is minus 13. So we're going to trace it like this and vertically up like this. Okay, to get our real point. So yeah, it links to minus 13, and if we roll it up, it will touch minus 3. Okay, so let's see another value of the table. Okay, the next value said we should link minus 2 and minus 10. So this is our minus 2 and this is our minus 10. So we're going to link both of them together also. Okay, so next we have minus 1 and minus 7. This is our minus 1. Okay, minus 1, minus 7. Minus 1, there will be our minus 7 because this is 6, so here will be 7, 8. So this is our 7, minus 7. So we're going to trace it like this upward. So let's assume this is where it touched. Like this. So this is the point. Touch 7, minus 7, and if you roll it up, it will touch minus 1. Again, we have now 0 and minus 4. The middle point here, this point is our 0, middle point. So already our x is 0 and our y is minus 4. So from this 0, we are going to trace it down to minus 4. This is minus 4. So here will be our points. So it's inside this place. Okay. So again, we have 1 and minus 1. This is 1. Minus 1 will be here. Since this is minus 2, here will be minus 1. So we're going to link where they meet. So we meet here and here. So we're going to put our points here. So we have again 2 and 2. 2 for the x-axis, 2 for the y-axis. This is the x-axis again. We have 2 here and we have 2 here. So we need to link them. Okay, so we're going to put it here. Lastly, we have 3 for the x-axis and 5 for the y-axis. 3 here. And this is our 5. Remember 4, 5, 6. This is our 5. So somehow from this and this position, assuming this is a real graph now, you will see the lines. So this one we're just assuming the location because we don't have real lines around it. So let's put it here. So it's touched the 5 and the 3. So we're done putting those points. So next we're going to do, we're going to roll all these points, roll the lines to touch all these points that we. Okay, so we've ruled the line. So it's because this is not a real graph. If not, it should have touched exactly the middle point of all this. Okay, but it still touched part of the points. Okay, so we've ruled the line. This is the line. Now this is the graph of it. Okay, so this is the line where it touches. So looking at the question said for in the A part, find the value of y when x is 2.5. So to find the value of y when x is 2.5, find the value of y. So I want to find the value of y when x is 2.5. This is 2. 0.5 will be the middle. 2.5 is like the half. Is in between 2 and 3, kind of like the median. We do the median of 2 plus 3 divided by 2 to give it 2.5. So 2.5 is around this location here. It's in between them. Okay. So if we link it up, if it wherever it will touch, okay. So let me just link it kind of. So wherever place it touches this place. We're going to then link from this place to the y-axis. Okay. So this will be our y. So when the a part, when x is 2.5, the y is, well, what is this point? This is our 2, this is 3. That means it will be around this range here. So here will be, let's assume it is 3.5. As it's a real graph, you'll be able to know the exact number. Okay. So since this is 2, 3, 4, that means in between 3 and 4. So let's give it as 3.5. So our y is 3.5 when x is 2.5. So let's see the next question. The B part says that what's the value of x when y is minus 2? When y is minus 2, what's the value of x? So where is our y? This is our y. This is our minus 2. So we want to find the value of x when it is minus 2. So we're going to trace it to touch this vertical. This line will just do. Okay, this is where it touched. So we're going to, from here, trace it up to reach our x-axis. So this is the point where it is in the x-axis. Okay, so this point, you can assume since this place is 1, 2, that means this place is less than 1. So, but it's almost close to 1, so we can assume it to be 0.7. Okay, since we don't really know the real points, because this is not a real graph, so let's assume it to be 0.7. So you should give it 0.7. Okay, so that's how to locate the points. Since find y when x when y is minus 2. Since this is our y-axis, so from our point, from that minus 2, we're going to link it to touch this our line. So from that line, trace it up. Wherever it touches, that is the value of your x. So from here, it is 0.7. So the last question says that the coordinates of the point where the line cuts the axis. So where is the coordinate of the point where this our line cuts the axis? Okay, so it cuts the axis, all the axis. This line cuts this place, and it cuts this place. So let's say what is the coordinate of the point? So let's represent this place as A. That's this point as A, and this our second point as point B. Okay, so for this C question, our A for the point A, okay, so it touches 1.3 for the x-axis, 1.3 for the coordinate of this place. So there will be 1.3, and the y-axis of this place it touches is this place, which is 0. If you link both of them, this is 1.3 in the horizontal axis, but for the vertical axis, for this same point, if you link it, it will be 0. So we're going to put 0 here. Okay, and for the B point, for the point B, which is this place, it touches -4 for the y-axis, and for the x-axis, if we take it up, 0. Okay, so it touches for the x-axis 0, for the y-axis -4. So these are the coordinates of the points it touched. So we need to make sure you make your x should be the first one here, y should be the second one. The same way again, x should be the first one here, y should be the second one. This is kind of like x1, y1, x2, y2. Okay, something like that. So these are the 2 points where it touches for this A and B. So we will solve this problem Hope you understand. If you don't understand, replay this video so you understand it very soon. Thank you.